Hey there, it's Shannon MATHCHICK Myers, and today we'll be looking at finding indefinite integrals using trig substitution. And specifically for this one, we're doing part one, which is using the a sine theta substitution. Now, if you didn't do the warm-up, please do so. I'll put a link to it in the description. If you don't do the warm-up, you might get a little confused about what I'm doing in this problem. All right, here we go. If the integrand has a square root of a squared minus x squared, or you might have a function of x. So you'd have an a squared minus u squared, and no basic integration rules, integration by parts, or regular trigonometric integral techniques work out, we can use the substitution x equals a sine theta, or you might need to do a u substitution prior, so u would equal to a sine theta. Cool? Okay, so this one, we just have a simple x squared. We don't have like 2x, the quantity squared or something like that, so we don't need to do a u substitution. Now I'm looking at this integral, and it would be great if I had a constant over this square root of 4 minus x squared with respect to x, but we don't. So, hello trig substitution, do your thing, right? So, since it's an a squared minus a u squared situation, actually an x squared we're keeping it, a is equal to 2, and then we're just going to keep it in terms of x. So x is equal to a, which is 2, times sine theta. We're going to need a few things. We're going to need to know what dx is. So dx will be 2 times cosine theta d theta. Don't forget the d theta. Now, we also want to isolate sine theta, and it will be x divided by 2, working from the x equals 2 sine theta equation. And then, just in case we need theta, a lot of times you'll get theta in the integral. Do you see if you evaluated the arc sine of both sides, you would get theta equals arc sine at x over 2. Now, to make our triangle, hey, don't you love technology? We would have our theta here, and this is a right triangle, and then we know that sine theta is x over 2, so that's side opposite over hypotenuse. And if you did the substitution correctly, you'll get your square root that you started with. And we did. We got root 4 minus x squared. So we'll be using that later. All right? Now, the square root of a squared minus x squared is going to equal to 2 squared minus 2 squared sine squared theta, because 2 is our a. That's going to equal to the square root of 4 minus 4 sine squared theta. You may have memorized that this is going to end up being 2 cosine theta. If you did, that's fine. Factoring out the 4, we'll be left with 1 minus sine squared theta. And then we'll get 2 times root cosine squared theta, which is 2 cosine theta. All right, good to go? Awesome sauce. So we have all this useful info on this side of the page, and then we'll come back to working our integral. So here we go. This will equal to the integral of, we just found out what our a squared minus x squared was over here. So our a squared, which was 2, minus our x squared, which was sine squared theta, we ended up getting 2 cosine theta. Good so far? And then d theta, remember, or dx will be 2 times cosine theta d theta. So this comes from over here, what we did earlier on. And now we can get going. So we will have 4, I'll bring the 4 out, times the integral of cosine squared theta d theta. Now we need to use that power reducing formula, which you learned in Calc 1 and you just relearned in section 8.3, the trigonometric integrals section. So this will be 4 over 2 times quantity 1 plus cosine 2 theta with respect to theta. Then we'll have 2 times the integral of 1 with respect to theta is d theta, is just theta. And then the cosine 2 theta, you're using a 1/2 to balance it out for this guy. And then you'll be using, because you need to have a 2 d theta for that part of the integral. And so we'll end up with 1/2 sine 2 theta plus our constant of integration. Good so far? Excellent. So now we have 2. Now, what was theta? Beautiful. We have arc sine at x over 2. And that was another one that was over on this side. And then 2 times 1/2 is just 1. All right, so I'm distributed the 2 to both. And then sine of 2 theta is 2 times sine theta times cosine theta, and we still have our constant of integration going on for us. I used a trig identity, by the way, for sine 2 theta. And then we will have 2 arc sine at x over 2 plus 2 sine of theta is x over 2. We had that from the start. And then times cosine theta, which is going to be the square root of 4 minus x squared over 2. So this is where I'm using my triangle over here. Okay? Plus our constant of integration. And then cleaning it up a bit, we will have 2 arc sine at x over 2 plus 1/2 times x times the square root of 4 minus x squared plus our constant of integration. And we're good to go. How are we doing so far? Good, good? Awesome. Keep at it. You got this. I know you do. All right, so that wraps up our example portion of our trig substitution for a sine theta. I hope you have a wonderful morning, afternoon, or evening whenever you're checking out this clip. And if you like what I'm doing, please hit that subscribe button, that like button, and share the video. Be sure to watch the next part of trigonometric substitution so that you can find out all about the a tangent theta substitution. Bye.